Okay, let us work on figuring out the electronic configuration for titanium. Titanium, if you look it up in the periodic table, is element number 22, which means that it will have 22 electrons. Okay, now we're not dealing with ions right now. This is a neutral atom, which means if it's element number 22, that means that it has the same number of protons as it does electrons. Therefore, it's got 22 electrons to populate over here. So once again, we start from the Aufbau principle, tells us to start from the lowest energy level and work our way up. And the Pauli exclusion principle says that each of these lines here, each of these orbitals, can take 2 electrons with the spin paired. So I will put 1 electron here, and then because I have plenty of electrons, I can come back and I can pair that electron up. So I've used 2 of my 20. I move on to the 2s orbital, and I can also fill 2 over there. Now, Hund's rule tells us that I have to maximize the number of unpaired electrons when I have orbitals like this that are the same energy level. So I put 1 on each first, get in the habit of doing it even though you have plenty of electrons. That way you don't forget. So 1, 2, 3, and then because I have enough electrons, I can come back and I can pair them up. So 2, 4, 6, 8, 10. I've used 10 of my 22, which means I have 12 left. I can use 2 here, which means I have, 2, 4, 6, 8, 10, 12. Now I have 10. Once again, get in the habit of putting 1 electron first in each of these and then pairing them up. So 12, 13, 14, 15. Now I can come back. 16, 17, and 18. Okay, I have 4 more. Now note, the 3p doesn't go, now we don't go to 3d because that's higher in energy than 4s. Do you see where 4s is? We have to fill this first before we move to 3d. So I had 18 to here. 4s will take 19 and 20. Now I have 2 more electrons, and they have to go. Now we have to go back and fill the 3d orbitals. And because of Hund's rule, I have to spread them out. So there's one, and there's the other. And then I ran out of electrons. Double check, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 electrons. This is the electronic diagram. Now I need to write the full configuration, and I start by writing each orbital and how many electrons they have. So I start with the lowest one, 1s, and that has 2 electrons. Now my 2s also has 2. My 2p has 6. My 3s has 2. The 3p has 6. The 4s has 2, and then the 3d also has 2. Okay, this is the full configuration, electron configuration of titanium. We also talked about the shorthand notation, and we cut off the beginning part, which are called the core electrons, and those are the electrons that correspond to the nearest noble gas configuration. For titanium, the nearest noble gas configuration is going to be right here. This part here, and I didn't do that well, but there we go. This part is argon. So argon has this configuration right here. And I can replace all this by just saying argon, and then the rest belongs to titanium, 4s2, 3d2. So this is my shorthand configuration for titanium. Notice that titanium has these 4 electrons over here are electrons that are valence electrons. the argon, whatever it has up to argon here, these 2, 4, 10 plus 6, 16, or 2, 4 plus 6 is 10, plus 8 is 18, so those 18 electrons are considered core electrons. And then what comes after that, the closest noble gas, those electrons are considered the valence electrons, which are the ones that we really deal with because they determine the chemistry of that particular element. For example, titanium a lot of times will form just a +2 ion because it will lose those 2 unpaired electrons and then have everything else full. Or it could even lose these to get a 4+. So that is, we're interested in that because that's where the chemistry happens. Okay, for the next problem, we are going to work on nickel, which is on slide 29. And nickel, I'm just going to kind of continue with a different color here. I'm going to continue nickel because it's very similar to titanium. Nickel is element number 28, which means that it has 28 electrons. Okay, and titanium was number 22, so we had 22 up to 22 here. Okay, so we had 22, then we have 6 more to fill, and I'm going to do 23, 24, 25, and then have to come back to pair them, 26, 27, 28. So I used up 28 electrons. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, so if this was my titanium, let's work on the nickel, just so we can compare them. I didn't erase all this because they're very close to each other. So let's start writing the full configuration for nickel. It is 1s2, right? I got 2 electrons. 2s has 2 electrons, so 2s2, 2p6, 3s2, 3p6, and then I go to 4s2, and my 3d is 2, 4, 6, 8, 3d8. This is the full configuration for nickel. Once again, if I want to do the shorthand notation, I will cut it off here. This is the argon configuration, this much here. Oops, I want to keep that 6. So this is argon. So the shorthand notation then will be argon 4s2, 3d8. And this is the shorthand notation for nickel. Okay. I will erase this and then we will move on to looking at some ions instead of just atoms like we've been doing. They're very similar, they follow the same pattern, but instead of being atoms, they are ions, so we're going to have to fiddle a little bit to try to figure out the correct number of electrons.